What's up, Michael? Hope you feel better when you watch this. Or if you're not feeling well. This is number 44?
Yeah.
Of homework 4 that we're just going over, and then but he didn't even leave his homework. So I'll have to click that one. So Jonah is just showing his work on number 44. Okay, so this should all be over H. And did you get this far by yourself? But then,
Well, I plugged in 2 over 4 plus H minus 1/2.
okay,
Which
Yep.
should work as well. That's why I didn't figure out the other problems. I must have missed something in the rest of my. Because my final answer would have been, I got to -1 over 8 plus 2H. So somewhere something didn't cancel. That should have.
So, like I said, I just started with this, and then if you can plug this into the equation, you get this stuff, and then minus that. And then if you distribute these out both ways, and just cross multiply, then that gets you this equation up here. And since the denominators not the same, you just put it over this. And since you have 2 denominators, you can pretty much, I think there's a law in algebra about this where you can just bring it up. And then you can
multiply by their reciprocal, so yeah.
You just bring it up. And then these 2 h's cancel out, and that leaves you with this. And then if you distribute this term out here, then that will leave you with x squared plus h deck, or hx. And if you, since it's the limit of h approaching 0, we can substitute 0 in for h, which cancels out this term. And that will leave us just x squared, -2 over x squared. And if we substitute in,
So you got all the way to here?
Yeah.
And then
I
just need to put the
I just
11
need to plug it there. Yeah.
Okay. Yep, that tracks. That looks great.
Sick.
Good. Every step is accounted for.
Yay.
Awesome. Go look at all this work. All right. We won't have the TV for a few minutes, but that's okay because we can do what we're doing today on the whiteboard. But I can collect your stuff while I'm thinking on it. And let me check. Yeah, there should be a staple over there. Awesome. So yeah, both homework same 4. Okay. And then we'll do the memory work real quick as well. And Michael, you can just follow along on the recording. That'll be fun. Looking at your computer, just quoting the memory work. I am impressed by that.
Really?
Cleaning out your notebook like that? I always mess those up. I can tear perforated books, but I struggle with notebooks.
So
Like the Saxon books, those are so easy to tear out of, but I always mess those up.
The trick is to get it started at the top and then move your hand down so then it levers up.
Yeah, and that's how I do it from the books, but then on notebook picker, I just rip it. I don't know.
How many pages did you have, Jonah?
A lot. Too many, actually. So many to where I was questioning myself. How many pages do you have?
Michael, I will encourage you, I'll send you this email,
2
but
for each.
Yeah, from that.
I officially don't accept late work according to the syllabus, so I would encourage you to send me a scan and copy of your homework through
I guess I read some.
Gmail.
I didn't leave
That being
Jonah's
said,
pages.
you also have 2 oops moments that you can use to turn in your work 40 hours late.
I can help it.
And so if you want to use one of those times, then you can do that and turn it in on Friday in person.
Pages.
I'll send you an email.
Mr. Hattie, you're gonna have fun. She got them on 2 pages from that.
She writes really small.
I write small. And I play Tetris with my problems and
Yeah, she does.
put them inside each other.
It's impressive.
No, I messed it up. I was having to scream. It's okay.
It's a book.
Literally,
It's literally a
literally
book.
I gotta make sure I didn't miss that.
There aren't that many pages left in there. That's okay.
I should start the one with different sections.
It's so nice, especially for graphing things. You can just follow the lines. And
This
blocks are
sounds
one space too.
I just use printer paper. I hate the lines. They ruin all of my work. Because now that we're using like the difference quotient all the time, I'm like, well, I can't just write it in one line. So then I just.
Yeah, be great over 2 lines. That works with graph paper. It doesn't
but then it
really
just
work with
gets like
lines.
so tight and messy if I try to follow the lines. So I want to like skip an empty line so it's more, and then it's like now I'm taking up all this empty space. That's why I just use this actually.
This is a 2 staple kind of book.
Cool.
That's insane.
All right, thanks.
Yeah.
All right, here we go. What is calculus?
Calculus is the study of change, both instantaneous change and the accumulation of change.
I'm gonna skip Ecclesiastes 3 for today, just for time. Let's see how we're doing on why should we study calculus.
The river,
Curve of a river
the
bank,
stars,
And the
I forgot to make slips for you guys.
path of the
sun.
I
All
don't
true,
know.
all true.
Okay,
so we
these
can live on
things-
of change.
Okay, it's fine.
Yeah.
Because I don't have a TV, we're just move on. All right. So, great. Just keep where you are. We have been, so yesterday, Monday, you were taking the derivatives at a point, which is great because that's what we've been trying to work for this whole time, is trying to find what's the rate of change at this point. But I kept a secret from you. Another secret. I'm still hiding secrets. We can actually use our limit definition to just find the formulas of f prime as well. And then we'll just know all of the points.
What?
Yeah. So that's what we're going to do today. So let's use our beautiful difference quotient to find the formula of f prime of x given a different f of x. So let's find f prime of x. Thank you for already writing the difference quotient up here so I don't have to write it. And then we'll just do a really simple f of x equals x. All right, we'll just use a difference quotient to find the formula for f prime of x. Now, what you have been doing is I will give you a value of x, and I'll say, I want you to find f of 4, and then you plug 4 in for x, and you do all the arithmetic to find what that value is. Well, why can't I just use an x and just find out what's going to be true for all the x's? Because if x representing a number works the same way as a 4, works the same way as a -3, if this is just standing for a number, let's just find out what will happen with all the numbers, all at the same time. That's the idea.
That's
So-
what Jonah did, isn't it?
Yeah, actually, you pretty much already
Yeah.
did it. Yeah,
Wait.
so you pretty much already did it without me telling you. Yeah, because you found the formula and then you plugged in your value and then simplified, which is great. That's totally fine.
I didn't even realize I was doing
Yeah.
that.
Yeah, so
Yeah.
you are naturally taking the next step, which is
Yes.
fantastic. So, all right, that's why I wanted you guys so badly to do derivatives of a point yesterday, because then if I teach you this, then you're going to be like, well, why are you making me do this? Because I already know. So, here we go. Find f prime of x. So, we're going to take x, and we will plug it in for f of x. So, here we go. F of x plus h, we'll take this argument and put it in for x.
X plus H.
Bingo. It'll just be x plus h.
Would
Actually, maybe stay left so that Michael can see.
it wouldn't be. Why would it be x squared plus h?
You're plugging that in for X, not multiplying it by X.
Yep, so I'm taking, so this is our difference quotient. I'm taking the argument x plus h, and I'm plugging that in to everywhere I see an x in my f of x function, which is right here. Simplest function you could have. So I'll just take x plus h, plug it in for x, which just gives me x plus h. So then I'll take x, and I'll plug it in for x. Well, that was easy. And then I'll just keep the h.
So 1.
Yeah, you already see the end. But we can just write those steps out. So it'll be, these will cancel. So I'll just have h over h. And then the limit as h approaches 0 of, that'll simplify to 1. Then I plug my limit in. There you go. So there's all the steps written out. But yeah, you can see it from the beginning. So this one is the formula for f prime of x. So f prime of x equals 1. And it came from this f of x function, which is 1. So for any x value you ever want to know about, for this function, heck, 5 million, what's the rate of change at 5 million? 1. What's the rate of change at negative 732? 1. What's the rate of change at 0? 1. That makes sense because in x, you just have a 1 here in front of the x. It's invisible. But this is just the linear function for you guys, y equals x. Is the rate of change everywhere along there just 1 over 1? Yeah, absolutely. So we actually knew this without needing to do all of this. But this shows you that we can use this to just find the formula. Okay? Now we'll upgrade. We're going to do f of x equals x squared. Let's find f prime. At this point, you'll definitely want to copy down. You didn't copy this one down already. You'll want to copy down from now on. So, yeah, I would probably rename it at this point because that's why we do different functions. So I'd probably say like g of x, but because I already have it written, I'll just leave it. Okay, so all we do is here's our f of x. We want to find the derivative formula, so we'll plug in this argument in for x to start. So limit as h approaches 0 of f of x plus h will be x plus h squared, right? Minus x squared, because f of x is just x squared, all over h. And now we use our algebraic case. If you can go faster than me, then go ahead, but I'll try to keep us moving here. If you aren't sure what I'm doing, just stop me and ask. You can see that, Michael. Okay. Okay. That 2x is our formula for f prime of x. This is not surprising because we did this a few weeks ago, where we thought, oh, well, if I take x squared and I find some points along the way, what the slope is, my guess is that it's something like 2x. We did that a few weeks ago, where we just took a hypothesis at what the formula is. Now we can just find the exact formula. And we were right. We figured it out correctly. It is 2x. So f prime of x when f of x is x squared is 2x. This is incredible. Like, the fact that this works is amazing. This should blow your mind. Like, this is like a watershed moment. Like, this is incredible. Because if you can just find the formula for any function, just plugging it into the difference quotient, that's incredible. Because now we're able to actually find the specific formulas for derivative functions, and then we can calculate the rate of change anywhere. And then we could do even more with it.
For f double prime, would you just plug in 2x?
Great, let's do it. Let's see what happens. let's do f double prime of this. So let me just use a color at this point. Go ahead and start working on it if you know what you're doing. F double prime of x is going to equal what? I'll take this out. Probably leave all of this. Okay. So I'll have my limit as h approaches 0 of 2 times x plus h minus 2x over h. Okay. And then I can distribute the 2. And we should get 2h over h, which will equal 2. This is, I mean, the fact that this will always work, like you will always be able to like cancel out these terms that don't have an h in them and only leave you with terms that do have an h in them. I mean, this blows my mind. Even like I know this, it still blows my mind that this works every time. It's amazing. And so the fact that we can simplify down to something every time because those h's will cancel is great. Thank you. Yeah, there's supposed to be 3 and one of them's not here.
Oh, there's only 3?
Yeah, call him a slacker. 7th graders are calling you out. Just kidding. I'll just leave this until we finish this. And then I'll look it up on here and we'll have our notes saved.
It fell off.
Oh no. Yeah, it does that. Thank you.
It's okay. It doesn't
Has no meaning in life.
We don't need that one.
Unlike a difference quotient. So this is awesome because every time you plug in f of x plus h and f of x, you're always going to have like your beginning and ending terms will cancel out. Doesn't matter what function you start with. You can start with the ridiculous 3x to the 7th plus 2x to the 6th and like whatever, they'll cancel and leave you with terms that just have h's that will cancel. And then when you plug in your limit, you'll have a nice neat formula. That's amazing. Okay, let's just keep going. Let's do f of x is x to the 3rd. Go ahead and do that one. That one will take a little bit more algebra, and while you do that, I'll set the TV. Bro, you are already on the correct HDMI and then you left. It's like you knew the right thing to do and then chose not to. For him, it is sin. Okay, I'll see what you just take a peek and make sure that this is framed okay.
needs to be up a little more. There we go.
Okay, thanks. Okay. Going okay? Remember how to take parentheses to the third power? So I'd already set up our notes last night for what we already just went through, but so you guys did that already, and we did this one already. This one's on the whiteboard. Okay.
Oh wait, there's another one at the end. Oh my gosh. I forgot about that.
Minus
Yeah. There you go.
You would cancel out your H's. Yeah, just the X cubes cancels. And then you cancel all your H's. Wait, what did you cancel? Oh, it's no.
Alright, Jonah, are you here?
I think I'm doing some. I'm getting mixed up somewhere.
Okay, are you at the top step or the bottom step or in between?
I'm distributing x plus h, but the cubed ones throw me off. I think what'd you get for the distributed two?
Is there an algebraic property like the ones for where you have a squared, like a factor squared?
Binomial.
Yeah, binomial. Yeah, squared
Oh,
binomial. That's
hold
right.
up. Wait.
Where you have like x squared plus 2 xh plus h squared. Is there something like that for x cubed? And it comes always
For a
comes out to
binomial
that?
cube, yes, and for the fourth, yes, and for the fifth, yes. If you have no coefficients on your two variables and then you have whatever power for your binomial,
Yeah.
there's a formula. But it's usually unhelpful
Okay.
after the third. Like if you want to memorize this one, is fine.
Yeah.
Because this one's easy to remember that your coefficients would be 3. But once you do the fourth, which we're going to see in a minute, you'll have like a 4, a 6, a 4, like
Oh yeah.
harder to remember what the
Yeah.
coefficients will be, so it's easier to just work it out, or like, I don't know,
Yeah.
Google x plus h to the 4th power expanded.
Yeah.
Will be far faster than doing it by hand, but you can do it by hand. And is easier than memorizing the formula. So. Yep, okay, so you got to this. You're good? Okay, and then these cancel. So then we get to these h's, and I already crossed them out. So then we get just this. And now if I put my limit in, what will happen to this term? Did I get that?
I had 3x squared plus 8 plus x.
I did too, but I realized I
Well, that's
missed an h.
Oh, that
I
was
canceled.
an
I
H.
crossed off the squared for it, but then I forgot to write the h down.
Oh yeah, this x is easy to miss right there. Is that what you're talking about?
I had that x, but I didn't have the h that goes with it.
Yep, there you go.
Yeah.
Yep, that's easy to miss. Yeah, if you have squared and then you cancel 1 out, you still have 1 there, but
Right.
yep.
I hate doing these long terms. Like it's so turnaround. You start doing them and you're like, oh, there's an x there.
Mm-hmm. Yeah, it can be easy to miss those details. If you run into the point where you have, not all h's, you know you did it wrong because you gotta cancel the h at the denominator at this step if you don't have all h's in your terms. Then you know you did something wrong because this h should always cancel out. As for what's left down here, you could have, well, pretty much anything you can imagine, depending on the function that you're trying to take the derivative. Okay, what will happen to this term as I plug h in approaching 0?
It becomes virtually nothing.
Becomes virtually nothing, it becomes 0. Same with this one.
Yep.
Okay? So these become 0, so then you have 3x squared plus 0 plus 0. So anything added to 0 is just itself. So then our formula for, I think I wrote this maybe as g prime of x up above, I don't remember. Nope, I wrote it as f of x. For f prime of x here, whatever you chose to name your function, be consistent in your notes, is 3x squared. So when you have f of x is x to the third, the derivative function is represented by 3x squared. So if you want to know the rate of change at point 500, just plug 500 into the derivative function. That will tell you the slope on f at the point 500.
Can we try plugging that one?
Sure, let's plug let's not plug 500. We'll use your calculator. Use your calculator. It'll be 25,000? 250,000. 250,000 times 3. So 750,000 is the slope. At point 500 on f.
Which makes sense. It's x squared, so it would be really steep by that point.
Very steep. Yes, that's right. So your slope is basically a vertical line. But not quite, because it can't be, otherwise it's undefined. Crazy. But you could then do nice values like 0 and 1. You can find the slope of those points too. 500 is just to show you it works for everywhere. You could do negative values, tell you the slope. Which will be positive because it's squared. So, okay. All right, let's go another step here. I want you to see. Let's do, I think this is example 4 in the notes at this point, but I don't know what you've got going on for your system. Find f prime of x. Formula for f prime of x. Given f of x equals x to the 4th. Pro tip, use your work from the last one. Just multiply that by x over x plus h. Here, I'll put our work from So this would be your work from to the third, so you don't have to turn your page back. In the blue brackets, that would be x plus h to the third. Multiply the brackets by x plus h. Should get 8 terms, and then you could combine some.
Is there a better way to do this than just distribute it all up?
It's a really great question.
Because this is nasty.
It is nasty, isn't it?
All my plus signs look like X's.
Why?
I don't know.
Sounds like a you problem.
They should be a different direction.
I know. I get melded together.
Am I multiplying by a plus sign?
I don't know. Why do I have 8 X's? Makes sense.
Why is this one big term?
Why is my one term 2 pages long?
Handwriting is a virtue. Changed my mind.
It's true. A virtue I don't have.
Really, self-discipline is the virtue, but. Alright, I'm gonna go ahead and put the work here. And you can check yourself against mine. Please do work this out, it's for your good.
There's more.
Watch over half of these.
Guys, we're being tortured.
Poetry?
Torture.
Why?
It's a bajillion times.
Oh my gosh.
I'm only halfway.
They all factor that stuff?
Yeah, you want to factor
wow.
right now? What factors?
Is that a T or a plus?
Plus. I'm trying to
Plus.
figure out.
Yeah. The H's are canceled, don't they?
I'm so glad our variables are T's. That would really throw
That
me.
Yeah, wait until we have to use time.
No.
So
Are you
this is
going by
where
hours?
this is where you've probably noticed I write my T's like that on purpose because then they don't look like a plus sign.
That's good for you. It's pretty good. So helpful.
Only in math. I don't do that.
It's valid. Are you one of those people that like write their F's, capital F's with like a little line too?
These used to do
Huh?
that.
Do you write your Z's with like a dash in the middle?
Oh,
of it?
Z. You said F.
I also said F, but
Oh.
I
T's is what I think you were thinking of. People will do that with T.
Well, T.
Or
and
like
with F.
7, the like.
F
Yep,
already.
so I'll do that in
Sorry,
math class
T.
sometimes because I'll do like a Z or a 7 so that you don't think the Z is a 2
Yeah.
or the 7 a 1. So I will do that on purpose, but I don't do it in my normal handwriting.
How do you draw your
Yes,
eights?
yes, it does.
How you're supposed to.
That's how I do mine
My
too.
dad does 2 circles.
So does
I
omelet.
What a
can't.
weirdo.
That's yuck.
For eights? Yeah, I do.
Yeah.
That is definitely a yuck.
That's how my mom
Alrighty,
taught me.
we'll stop interrupting you.
Have a good calculus.
Yeah.
We will.
Have a good
We are. I mean, that's grammatically correct.
Have a good calculus is not grammatically correct. though.
Yeah, calculus can be a verb because what does it mean? It means to calculate.
Hope they're all canceling out.
Some history lesson, calculus used to just be what you used to call math. So like you would go to calculus class, but you were in 6th grade and you were learning about ratios, you know? But it was called calculus class. Way back when.
When I was wee lad.
Back in my day.
What?
I had 3hx cubed. How does that
Because
Because we had before.
yes, except you just need to multiply it, or you'll have another hx cubed term to add
Oh
it to.
yes, I do. Yeah.
Yeah.
Nice.
Did Michael go home?
Yeah.
Yep, okay, so this is all correct, and then y'all just want to combine like terms, which doesn't look like happened correctly here, because you have different work, so,
Well, it should all be the
like,
same.
these combine.
Yeah.
2x to the third h, no wait, 2, oh that's the third, where's the other one?
It should all be the same.
2x to the third,
Oh wait.
where's your, oh
Hold
here.
up, they're not opposite symbols. I missed a term.
Yeah, you should have all positives for your distributing there, so.
Hold on. These are.
Yeah, positive, 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 positive. That should be a positive. Oh no, that's your hangover. Okay.
That's-
Okay, that's where it's about. Okay, and then. Yep. Okay, and
These
then.
ones, these.
This should be a positive term, and
The
then.
negative h x to the third.
Yeah, because that x to the fourth at the end is just a tag along. It's not being distributed. That is your f of x part of the secant function.
But if you times it by x, then it just be negative x.
Yep, so what you did wrong is that you included this in the parentheses. So
Oh,
this shouldn't be in the
no.
parentheses at all.
Dang it.
So you just have two extra terms in here. So I think then you have. Also, this should be x to the fourth anyway, because we are dealing with x to the fourth. So f of x there is to the fourth. Okay. So then you can leave that then. It's technically okay.
But the h term.
But this
one
h
should
term doesn't
exist.
exist. That doesn't exist. Okay, so I think we should be perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, 12 terms. And then we should be able to combine those. So then you should get to 4hx cubed and 6 and 4, etc. Did you get it? Okay.
Well, I was almost there.
Okay, so you can catch your word. Alright, can you just spot what it's going to be before we actually get there?
Yeah.
I mean, you've already solved it. So.
I did.
But those h's are going to cancel out. Alright, so we'll have 4x to the third plus 6h x squared plus 4h squared x plus h to the third over 1. And we'll plug in 0 for h here. That will go to 0. H is here will go to 0. H is here will go to 0. So that'll just leave us with this. So then 4x to the third would be our f prime of x function. I really should be naming these differently because that's the point of naming functions different, but who cares? Okay. So there you go. 4x to the third. Crazy. Amazing. All of this, like all of this up here, this garbage, It just simplifies down to 4x to the third. That's incredible. All right, at this point, let's summarize. If I have, all right, f of x equals x, f prime of x equals 1. If I have f, nope, I'll change the names at this point. If I have g of x equals x squared, then g prime of x was 2x. If I have h of x equals x to the third, then h prime of x will be 3x squared. And then I'll just write down this line below. If I have k of x equals x to the fourth, then k prime of x will equal 4x to the third. Which one did we do for the double prime? Did we do g double prime here? Is that what we did? And that was 2?
Yep.
Or did we do this one double prime?
No, we did the.
Okay. Alright, we can add that in there. Just for fun. Patterns, observations, wonderances. Your wonderers are still broken, honestly, but patterns?
For all of them, yeah, the exponent becomes the coefficient and the power is taken down. So x cubed becomes 3 and the cube becomes squared.
So this is really easy to see with the blue, like this exponent moves to the front, and then it's 1 less. That's really easy to see here as well, the 3 goes down to the front, but what about the orange? Is it true there?
Oh wait, it's just the thingy where it goes, it's like the exponent and then it's the exponent minus 1 is the same problem.
Yeah, so like, yep, moving the exponent to the front, and then minus 1 on the exponent.
Like the equation.
The equation?
For the derivative.
Yeah, so you're trying to come up with like a general formula?
Well, no, there's a formula in the book that like models this exactly.
Did you read 2.2?
Yeah.
Wow.
No, but it was like earlier. It was something.
No, it's great. I mean, then you already know. But, spoiler alert, ruined it. I was trying to make Stop reading ahead. I'm kidding. No, that's great. Okay, does it hold for orange? Let's talk it through though. Does that rule hold for orange?
Yeah.
Yes. This is x to the first power. We don't normally write the 1 in the power because it's an invisible 1, but we can write it. And what's x to the 0?
It's 1.
1. What's 31 to the 0?
1.
1. What's anything to the 0 power?
1.
Right. That's a definition. That's something you should just know. So here I could write this as 1x to the 0. Because that is true. I took the exponent down by 1 and moved the exponent originally to the front of x. Now does that simplify? Yes, of course, it does simplify to just 1, and I could also not write that invisible 1, and that's what we found. Great, and then same thing with the purple, like you could add this 1 here if you wanted to, but it's invisible, so you don't have to. Okay, and then interesting here, like this would be x to the 0. We found the second derivative there on the whiteboard. Okay, let's take this pattern and let's find the second derivative of h. Uh-oh. Now what? Let's use our definition. We want to find the derivative of 3x squared. This one will be far less computation. Okay, so there's where we'll start.
I can have a theory.
Oh, you are just okay. I like that. So that'll cancel.
It is right.
6x. How, if we were just looking at this, do we get 6x?
Multiply 3 by 2. Drop the.
Yep, 3 times 2, and then 2 minus 1. So then we would have 6x.
Oh, you just do that in the first place.
Why don't we just do that in the first place? I admit, I was holding another thing from you.
No.
I keep holding
The
secrets.
trust is going down.
Okay, I promise I'm not holding any other secrets from you. Like,
Yeah, right.
you know all of them now.
I don't believe
This is called the power rule. Aptly named because we just take the power and we move it down, and then that's the power rule.
I remember using that on my test.
How?
I don't know. I remember I think Mrs. Connor
Great.
covered it in algebra 2.
Good for you.
Something.
I sincerely doubt it, but
Really?
there's no way she taught you the power rule in algebra 2. You wouldn't even have like a framework to understand it. Probably you were doing like exponent rules or like log rules where you move the exponent to the front.
Oh yeah, I was thinking of logarithms.
There you go. Those are different properties, but also really important. But
Is it kind of the same though? Sort of.
no, because you're not really finding the derivative. You're just writing it in a different form. So,
Oh, but I mean, it still works.
but it has the idea of moving the exponent to the front. But okay, what was I gonna say? Yep. So this is the power rule. Okay, great. So here's the power rule written formally. Power rule. I should have written this out in advance, but power rule is a theorem. It is not a definition. A theorem is different from a definition because a theorem says, no, a definition says, this is what it is by definition. This is what we're working with. So our derivative definition is that's the definition. This is what the derivative is defined as. A theorem is something that we're pretty sure is true. It holds for every situation we can think of, and we can prove it. But it's not a definition. We're not defining the derivative as the power rule. We're just saying our theorem is that this is how the derivatives will work. So if we have, how should I write this? A to the x to the b will be, let's say, if f of x is this, if f of x equals a to the x to the b, then f prime of x equals a times b x to the b minus 1. Okay, that's sloppily written. It's good enough. We discovered the idea. That is in your book, so if you want to go make a more formal theorem statement, feel free. That's sufficient. What you'll have tomorrow is, I'll give you this. You'll have 2 videos to watch. They're each about 20 minutes, so categorically. One of them you watch, and you will then email me either 2 things that were fascinating and amazing to you, or 1 thing that you still want to know about. Those instructions are on Google Classroom. The other video is this. Fill out the notes with the video, follow along. It's pretty much reviewing how to watch it. And then we questions 1 through 17.
Maybe
Except when you hit 10 and 11, just pick one or the other. Which means you're doing a total of 60. See you Friday. Keep yourself that far.